right, so today we're going to be talking about masters and minions, or the dream of Python automation. This is a topic that is, I love talking about automation stuff and infrastructure things and deployments and a lot of that kind of DevOps type thing. So we're going to talk a lot about DevOps, like what it is, what it means in the Python world, and how you guys can move towards that as well, and why you would want to do that, period. Don't hesitate to ask me questions along the way, and remind me to repeat the question if you do, because that way we get it on the recording. But I will go into this. There are certain things in life that should be handcrafted, like fine woodwork, jewelry, cocktails. I love a great handcrafted cocktail. But the thing I don't like are going to be handcrafted bespoke servers. There's no place in our infrastructure for these servers that have been transformed from bare metal into a beautiful, darling, unique snowflake that would host our applications and provide us with endless troubles later on as it proceeds to fail and be a miserable part of our life. The age of handcrafted servers is definitely over. With the advent of a lot of the public cloud and a lot of the services they bring, there's no reason for us to be managing that level of hardware. The term bespoke should be reserved only for clothing and not our servers that run our applications. You know, our beautiful, unique snowflakes are not reproducible. How many of you guys have run into an issue where an application's been running on a server for 5, 6 years, and now you have to migrate that to a new server because you need to upgrade the operating system, and you can't get it to run again? There's some magical combination of software that got installed over those many years. Actually, who's running the issue where that server's been up so long that you're afraid to restart it because it may not come back? Yeah, I think we've all, I have been there for sure. A little bit of trivia. The chances of a snowflake being exactly identical or alike is 1 in 1 million trillion. That is 1 followed by 18 zeros. That's a big number. And we don't, and there's probably that many beautiful, unique snowflake servers out there as well. And so we want to avoid doing that. You guys have probably heard this analogy, but I want to reinforce it for folks that may have not heard this. We should treat our servers not as pets. We love our pets, right? We give our pets names. We care for them. We feed them. If they get sick, we take them to the vet. You know, these servers we've kind of handcrafted, you have to do similar things. If they get sick, you have to save that server, or else your application may risk downtime for your company. This is actually well, I'll go to this. This actually was a analogy coined by a scaling SQL Server talk, but then coined by a guy in a blog post when he's trying to find the perfect analogy for why you'd want to move into the cloud and use more cloud-native technologies. So the idea, though, is we would treat our servers like cattle. And kind of missing a bit, on his ear, he has a number. And that's the only thing we identify him by is his number. And if that cow gets sick, we take him out of the herd because we don't want him to affect others. And we replace him with another fresh cow. Sorry for any vegans in the room. You know, it's just this common analogy that they use. But these things are replaceable. They can be another one can be put in its place and serves the same functions and serves the same purpose without having to go handcraft some server that makes our lives happy. Now the issue is we have in our current world of DevOps, we have so many non-cloud native applications, but we really have the ability to take some of those things and move them into the web easily to start deploying them in a more cloud-native way. And I'm going to show you an example of one we did with University of Notre Dame. So how do we take this handcrafted, beautiful server and turn it into a more cloud-native deployment? First thing we need to talk about is the rules of DevOps Club. The first rule of DevOps Club is we don't log into servers. The second rule of DevOps Club is we don't log into servers. Because logging into servers is the first way we end up with beautiful, unique snowflakes. You can't guarantee that someone logging into that server isn't going to try and make some kind of small change because they just can fix it right now. That thing will last for years and be a thorn in your side later. You guys are familiar with Fight Club, right? Maybe this is like the 15th anniversary of that movie. Third rule, these are all kind of, I tried to crib them a little bit, found some inspiration on Hacker News, but the third rule of DevOps, if your deployment fails, you roll back. For obvious reasons, you need to have a way to roll back. If you can't roll back, you're not doing DevOps. You're still handcrafting servers and trying to figure out problems in real time. The fourth rule, all artifacts will be stored in source control. So it needs to be a versioned canonical source of a way to roll back or to see the history of all the configuration changes that have happened across your infrastructure. Fifth rule, only one deployment at a time. You can't have your DevOps engineers focused on 5 things at once. They need to be able to focus solely on the one deployment that is happening right now. The 6th rule, probably my favorite one, no one-offs, no special cases. And I'm going to talk specifically about some of the gotchas we ran into around no one-offs, no special cases, because we went to great lengths to make sure there were no special cases in one of these projects. 7th rule, deployments will go on as long as they have to. I like to call this one maybe the continuous deployment rule. If we can actually get to a point where we're doing continuous integration and continuous deployment, we've won the war. As changes go into the code bases, tests pass, things happen, and releases happen in a very automated and consistent fashion. And the 8th and final rule, if this is your first night at DevOps Club, you have to push to prod. Actually, I know groups where that is one of the rules. If you get hired on day 1, you're pushing code to prod. Sounds scary, but I think it helps drive home the fact that you can go out and you can confidently release and you can break things because there is a way back, there is a way out, and we know how to do this in a managed, controlled way. So if we enter this world of DevOps, and we need to have a set of tools. The ones we're going to talk about are Python related, since this is Python Bytes. The Python has some great tools such as SaltStack and the AWS Spot03 library. So I'm going to talk specifically about those. And I'm going to talk about how we went from the closet to the cloud. The College of Engineering for Notre Dame actually deployed a site in about 2011 timeframe. This is like 3 years after EC2 went full production and had an actual SLA. So the cloud's still pretty young at 2011. But in 2016, only 5 years later, the university had a mandate university-wide that every bit of infrastructure is going to move up into the AWS cloud. So they contacted us about redeploying their app in a more scalable, a more sustainable, or more resilient way for the new AWS move. Take this opportunity to actually build a little more of a cloud-native operation. Now, if we look at the way that their application was deployed to begin with, it was a single server monolith. There's just one bare metal piece of hardware, not even running virtualization or any kind of containers, with all the various pieces running on it. So every bit of the web stack is there, all the Nginx, Varnish, HA proxy, all the various Plone is the application in this case. There's a content management system. There's 4 instances of that running in the load balance cluster, and then the storage backend for that thing, all on the same server. And I really do believe that this was sitting in a closet someplace. And it had a terrible network connection because we were monitoring from outside. We'd see all these outages. They're like, oh, it's okay. That's how things go here. I'm like, but it doesn't have to be that way. We can actually put you in a place where you have like a better uptime and more consistent connectivity. So the end goal where we're going with this though is to get more cloud optimized. Leverage the services and pieces and bits that actually AWS gives us. For example, replacing Varnish with the CloudFront CDN. Replacing HA proxy with the ELB, Elastic Load Balancers. These are now services that we don't have to worry about upgrading and managing. They get upgraded and managed by Amazon for us. Then we used EC2 instances for the Plone app servers, replacing out, and then actually allowing us now to scale that application tier horizontally. If we need to scale up for more traffic, we just add another instance. There is nothing on those EC2 instances. You'll see they're listed there as AZ1, AZ2. There's nothing in those instances that matters. They can be killed and brought right back, killed, brought right back, bring up 5 more. With our automations, they automatically get put into the load balancers for us. So those are now cattle and not beautiful pets that we have named so lovingly. In the back end, we now store any persistent data in Amazon's services. So we now use EFS for the blob storage and RDS for our database storage. Yeah, question? I probably wouldn't. The question was, because it was 2016, why did we not go with Docker? The nature of this application, there aren't like pre-made Docker containers ready to roll for this application, or maybe there are, but they're maybe of varying degrees of quality. And just based on our knowledge and how we deploy our current applications, I'll show you how we actually basically treat these EC2 instances like containers, because they're really running one application. They're not doing the database, the proxy. They're really doing a very specialized building block style piece of the activity. So to me, they're somewhat equivalent. I mean, Docker is really good as a packaging technology. We didn't need that in our case because we already had so I'll show the salt states that we use to kind of deploy these things and get them up to date. So that's why. And so with those persistence technologies in the background coming from Amazon, we don't have to worry about managing NFS servers. We don't have to worry about managing Postgres servers. Those are all managed and patched by Amazon themselves. If we want to then upgrade between generations, then it's a matter of just snapshotting and reloading data, maybe during a maintenance window. But I'm not replacing hardware anymore. I'm not dealing with Postgres versions and dealing with all the maintenance that goes along with that. So we've taken what was a non-cloud native application and made it look a lot more like a cloud native application. I wouldn't say it's fully cloud native because I think that would involve more pieces in re-architecture of the application itself. But I think this is pretty close. And then automating all the backups into S3. And we do it this way to make it repeatable. Now, how do we make it repeatable? We're going to need to use automation. It's too bad the picture's a little blurry, but that's a nice Rube Goldberg cartoon up there, if you guys are familiar with that. So if we take that automation and enter the tools for SaltStack and Boto3, this is where we start leveraging those tools to build our infrastructure in that repeatable way. The network end goal, so as you deploy into Amazon Web Services, you need to be able to deploy VPCs, which are virtual private clouds. And in our case, we needed to have the ability to quickly reproduce or stamp out different environments, like a production environment or a testing environment or a staging environment, and have a control VPC where we put our Salt minion. So the Salt is a event-driven orchestration layer that I'll talk about in a minute. But how do we bootstrap this? Because at this point, you still risk logging into the Amazon Web Services console, which is almost as bad as the first rule of DevOps Club. We want to be able to make sure that can be repeatable as well. So if something were to happen in this region, we could deploy the exact same infrastructure and setup into some other region. So to do that, we actually would go through a bootstrap process, kind of a chicken and egg here. How do we bootstrap our Salt master into that zone? And what we do is we actually wrote just some simple Python scripts using Boto3. I've got some examples here. Sorry about the text is a little small, but the slides will all be online. We actually want to get the Salt master, fresh Salt master into that region so that it can start now building the rest of the infrastructure for us. And we'll talk about the orchestrations that actually do that bit later. But you can actually see in here, oops, nope, don't want to do that. There we go. This little bit of Python code, there's just 4 lines right here. All that Python code does is create a brand new VPC for us to start launching our subnets into, putting our security groups into, launching our actual Salt master EC2 instance into. And once we've done that, we can now use that Salt master to control the rest of the infrastructure. So a little bit of Python code goes a long way here. One of the things I want to point out is some pro tips or kind of things you should watch out for. Be really, really careful about how you manage your AWS credentials. We want to make sure that no one gets their credentials exposed out to the greater internet. But we use LastPass. There's a really cool tool called LPassInv, where you basically can shove your LastPass keys into, or not your LastPass keys, but your AWS credentials into your environment for you, so that you can now use all the AWS CLI tools and Shell and Python and whatever you want, all from the environment variables as a much more standard way. And then when you close that shell, those environment variables disappear and they're no longer in your system, which is really awesome. So they stayed encrypted at all times. They're never at rest, unencrypted on your disk. They do, there's different ways you can do that, but I recommend using something like LastPassInv to manage that process. So we then go through and bootstrap the rest of our Salt server. Again, sorry for the small text up there, but basically we're going to use the user data attribute inside the Python script to shove over into our new EC2 instance everything we need to build our master. So we do not log into this server and actually type any commands. It spins up on its own. It uses the user data script to actually run through the process of installing a Salt master and making sure all the right repos are there so we can reproduce this over and over and over again if needed. You also want to make sure when you're scripting these kinds of things, AWS is very asynchronous and maybe idiosyncronous too. Sometimes there is random amounts of wait between when you ask for something to be built and by the time you actually get it. So you're probably either going to put some sleeps in or some checks in to make sure that the things are actually there before you move on to the next step. So for example, when you want to put the Elastic IP onto your Salt master, you have to wait for the instance to be fully up and running before you can do that. Even though you can put it in your script right away, it'll fail if it doesn't work there. Now we've got our Salt master in the cloud, we're ready to roll, we can actually take on our event-driven orchestration using SaltStack. So the nice thing about SaltStack is written in Python, so it can actually be extended in Python, but it's very easy to approach. All the states and profiles and all the pillar information, data about it are all written in YAML. So it's very easy to kind of approach and get started with it, and you can start very incrementally with it. The bit I like about SaltStack as opposed to tools like Puppet and Chef or CF Engine, which if anybody's using CF Engine, I'm sorry. Come talk to me, I'll help you. You can do things like remote execution, where other tools are primarily based around configuration management and bringing servers up to a certain specific kind of state for whatever application is supposed to be running. This one also allows for you to query your infrastructure in real time, doing things like event-driven orchestration. So as things happen in the infrastructure, maybe load increases or servers come online, you can actually have Salt manage the process of, for example, putting that server into the load balancer. So if you were to spin up maybe an auto-scaling group, or you spun up an additional EC2 instance to handle load, Salt can take care of a lot of those communications inside of AWS for you. It does work agent or agentless, although minions get very lonely if there's no master. It is possible to do it. It does support cloud provisioning. So the piece we're going to use here to actually build our next pieces of cloud infrastructure are going to be the cloud parts of SaltStack. And then another thing it has against a lot of the other tools in its favor is going to be speed and scalability. Like I said earlier, minions can get very lonely and very sad if there's no master. But it can run masterless, but they are definitely happier when you've got a master, and you can do lots of things at scale across all these servers in parallel. So what we want to do is put in place our master and minion. So there'll be a single master server, which we've already bootstrapped, and it's going to then now bootstrap the rest of the networking pieces, the rest of the EC2 instances, all those parts and pieces I showed you on the new cloud native looking infrastructure will all be handled by the SaltStack doing the orchestration piece. So the orchestrate is basically going to be follow this recipe, a set of steps. You're going to run through and bootstrap the network, bootstrap the VPC, bootstrap the security groups, bootstrap each of the pieces all the way along. The end result of running that first command up there is going to be a production environment that has all the networking pieces in place, all the cloud building blocks like RDS, EFS, S3, EBS, CloudFront, all in place and ready to go, and your application actually deployed to the EC2 servers. Like with zero human interaction after just typing that one command, you end up with this. So you'll have up here, our cloud network infrastructure, and in addition, all the pieces that make up our full cloud application running inside those various VPCs. With, again, zero human interaction. Now, in addition to getting you bootstrapped with a brand new environment, we also want to automate all of our code releases. The end users want to be able to release code whenever they want on their own schedule, and I don't want them necessarily logging into servers. Again, first rule of DevOps Club. So we typically build these orchestrations for our end customers to be able to release code on their own by logging into the master, running an orchestration, and releasing code. So if we look at that, the orchestration can actually loop through each server. So you can see this is Jinja templates using SaltStack states. Well, actually SaltStack orchestration. It will just loop through every app server that it discovers, and it can actually discover all the app servers that are currently running. So if you had added 2 more into the infrastructure since you ran it last, this will take that into account, run against those additional ones, do things like stopping the varnish server to take it out of load balancer, going through each instances or each clone instance, stopping those, and then checking out the latest code onto that server. Once we've checked out the latest code, we'll run what's called build out. We may even have to do some gulp functionality where we recompile our JavaScript and CSS. That can all be handled so there's no human interaction and we don't miss a step along the way. Again, humans are very prone to error, and we want to reduce any way that they can introduce errors into our environment. But the SaltStack's not just for releases. We use this for any kind of task we can do across our infrastructure. So for example, a common task that the users may have is getting data from their production machine back to a staging server. Say they set up a fresh staging server, but they want to be able to test a release against actual production data. So we've written orchestrations that can actually move data back and all the steps that go in between, because it's actually a tricky process sometimes. You may have to dump the database, synchronize the blobs, because actually Zope stores the blobs separate from the database, so they have to be in sync with one another. Stop the various instances when you do that operation, rsync data back and forth, so you aren't transferring the whole thing every time. So you can just kind of see the list of steps that all add back up. Drop the database, recreate the user, reload the dump that came from the other server. So another feature of the orchestrations is the ability to do these things across servers inside the infrastructure. Typical configuration management is going to manage things happening on one server. So the configuration of a single server, the orchestrations allow you to do that across multiple servers. And another feature it has is the ability to do scheduled tasks. So we have the ability to now, say, take database backups, throw them on an NFS share once a night because their VMware snapshot-y thing was basically causing the networks to time out because it would freeze the whole instance as it took a snapshot. This is a terrible idea. I don't know what they're thinking, but we worked around it by using Salt and some database dumps in a more manual process, and now they just back up the NFS mount. Now, I mentioned we can do this across multiple layers, across multiple servers. One thing I ran into when I actually wanted to be able to do this is if I wanted to query across my environment for sets of servers and find a specific kind of server. So in this case, I'm actually querying for the Postgres master. I want to be able to find the master so that I dump off the slave and I load onto the development environment's master. So it's important because those could be, there's typically a cluster of 2 servers here in each environment, one of them master, one of them slave. I don't want to read off the production master because it would affect performance, and I don't want to load onto the development environment slave because then I'd create a separate master that would be disjointed from the other master that has the old data. So we can actually read across that data inside of Salt by looping through and running a Salt command against the server. In this case, we're running looking for a file var run keepalive.d or keepalive.state and looking for the word master in there to try and discern which box is currently master, so we can now do our operations based on that variable. Unless you nest loops, which if you guys have read this in a Python, you know that flat is better than nested. You cannot do that in the current version of Jinja that ships with SaltStack. On the other hand, Jinja 2.10 does support namespaces, which allows me to create variables outside of loops and then use inside the loop set a variable in the loop. Because when you exit that loop in Jinja, if it's not using this namespace feature, that variable goes away. It's very heavily scoped on the loop, so any variable created in the loop will go away after the loop is gone. But you can upgrade your Jinja to 2.10 with your current SaltStack installation and actually leverage this feature for cleaner state file templates. So now in this case, we set up a namespace for the dev master, and then later we set up one for the production slave, and now we can use those variables later on outside the loops safely. So just a little tidbit of information if you're trying to do this, because I racked my head for probably 2 days trying to figure out how to get this to work. All right, switching gears just a little bit, we're actually going to use Python now inside our same cloud, inside the Amazon public cloud, to save us some money and actually ensure some compliance. I've given some talks about Cloud Custodian in the past, but I wanted to show you guys a quick little snippet of some Cloud Custodian. Cloud Custodian is just a cloud compliance tool that is fully event-driven, much like Salt, and allows us to watch for things happening inside the environment, and also allows us to react on a schedule. So for example, if we want to set up office hours for the developers to have instances in the cloud, those instances don't need to be running in the middle of the night. We can save money. We can save about 2/3 of our bill on the development instances by just shutting them down the 2/3 of the day that they're not at work. So we can write our policies in YAML. This one's a periodic policy, so what it does is it sets up a Lambda inside of AWS automatically for us. And with a schedule of every 1 hour, and in documentation you can set up different kinds of schedules. And then we run looking for filters of a type off hour and run stop. And then vice versa, in the morning we would run the same kind of off hour looking for, or on hour looking for start. So in this case, it's going to stop the instances at 4 o'clock every day. And so in Notre Dame's case, we did this for them because they typically aren't testing anything until about the afternoon. All their instances, including RDS, can be spun up and down using a schedule like this to save money inside the cloud. There is a Cloud Custodian talk up on the YouTube channel from about a year and a half ago, but it's still very, very relevant to today. I know I made this sound all very easy. Actually, in my day-to-day job, I've tried to strike the word easy from my vocabulary. Matt's laughing, but I have been trying very hard because nothing is ever as easy as it sounds. The road was definitely bumpy for sure. Satisfying the rules for no special cases was tricky. This is where it gets back to the DevOps rules of no special cases whatsoever. So keeping in mind the Zen of Python. Who in here has read the Zen of Python? Hopefully everybody. If you haven't, open up your Python interpreter and type import this. And this is one of those Zen of Python statements, which is that there should always be one, and preferably one obvious way to do it, although it may not be obvious unless you're Dutch, because creator Python is Dutch. So to get to this repeatable process where we didn't have these special cases, we had to go through 3 iterations of different operating systems. I thought this would be a really great opportunity for us to try out Amazon Linux. We're going to be deploying into Amazon. Might as well use their AMIs for their version of Linux, because certainly it's going to be like way tuned for better performance. Oh boy. So we started off with Amazon Linux, only to find out that the package repositories in Amazon Linux were too old for a specific version of WV we needed, or for the dependencies we needed to build WV, which is a document converter that runs inside the content management system. Okay, trying to stay in the Linux theme of things, like let's try CentOS. CentOS 7 had just come out, I think, at this time. It's like in 2016 timeframe. And these 3 commit messages are all within like 1 week, I believe. Is that right, Matt? I think it's all the same week. So we refactored it to run on CentOS 7, which is awesome with SaltStack, because you just had to change a few mappings. You can actually make your salt states cross-platform, so we could run it across all 3 platforms simultaneously with the same set of states. So we changed a few things, refactored CentOS 7, only to find out that CentOS 7 has too old a version of HA proxy. And we were trying to do our rewrite rules in HA proxy, and so we needed a version 1.7 or better, and theirs was too old. I was like, oh. Last and final straw was go back to FreeBSD, my old standby. I've been a FreeBSD user since 1996. I love it. I try not to force my opinions on others, so I try to be lenient and tolerant. I try. I didn't say I am. I try. It's like I try not to use the word easy. So we refactored for FreeBSD, which actually has a very modern package manager and had all the versions of the software we needed, because one of the things I wanted to avoid here was not installing custom repositories for any of the operating systems we would run. Whatever we ran, it had to come native out of the box with the package managers that were supported by the vendor of the operating system, so that we were sure that those things would be supported moving forward. So in the end, be careful which things you choose, and be careful not to make special exceptions here. Yes?
I was just going to add, on the Amazon Linux compared to the CentOS or Red Hat stuff, we went through an analysis. The Amazon stuff is much more locked down. They actually get 98% out of the box, 98% CIS compliance compared to the 3% compliance.
Yeah. Yeah, so talking about the kind of level of lockdown of Amazon Linux versus like CentOS.
I'm the SEC part of DevSecOps.
Yes.
And I was concerned about that. That's one of the reasons why the doctor did the question beforehand. And so when you make if you're going to make some changes and things, you need to maybe look at some of the security things too. You get a bonus for going to Amazon Linux.
So yeah, the comment is you may get a bonus in the security standpoint when going to Amazon Linux, because they do. Sounds like they take a lot more care in feeding in their AMIs to make it a little more secure. So again, you have to weigh your costs and values and what threat targets are. In our case, doing FreeBSD meant a lot less work on our side to maintain either custom repositories, or we had considered compiling from source, which is a really bad idea, and probably worse from a security standpoint, because you'd have compilers on the machines. The goal here would be 0 compilers, no compilers on the machines. Like this is still relatively secure, especially for the value of the target. There's no personally identifying information on these servers. It's probably a relatively safe operation for us to do this. So keep that in mind, that choice of distribution will greatly affect your happiness later. So some other recommendations based on our experience doing this level of automation. Using a continuous integration strategy would greatly improve our life, I think, moving forward. Salt has a tool called Kitchen Salt, which allows you to take your existing salt states and you can actually split them off into kind of more modular formulas. So maybe in certain instances you do need varnish, in certain instances you just need HA proxy. You can split those off into their own testable tidbits and test them across multiple platforms. So Kitchen Sink allows you to test against CentOS or Ubuntu or FreeBSD, all with one test run, and you can hook that up to your Jenkins or your, whatever test runner you want it to run these against. The reason I would, actually the most important reason I would probably want to put that CI strategy in place, the Amazon web is an ever-changing environment. Their APIs constantly change, they're adding new features, they may change some kind of call method signature on the calls, and the documentation can be terrible, and you won't know it until you go do the next release, and it fails. And now all of a sudden you're debugging and trying to figure out why your cloud states to build up infrastructure aren't working or acting odd. If you were to have a more automated process that was actually doing a proactive check against the infrastructure, maybe build up an infrastructure on a scheduled basis to detect when Amazon changes their APIs, it's something I would love to put in place for this project. Another nice thing you can do with Python is you can actually really easily build your own tools. In this case, we were doing tracing of requests coming in through CloudFront, and we wanted to be able to see what the result was, whether they were being cached, whether they were being passed through the origin or to an origin server, or what the response was from the origin server. I built a little tool called AWS Log Tools. There's a CF logs parser in there that will actually go out to your S3 buckets, and it uses the Clint library. I was talking to these guys about this just yesterday, to produce some nice menus. Pick which CloudFront log file you want to look at, and then produces nice colorized output with the columns all colorized, so it's easy to view what's going on or highlight certain data in the logs. Without that kind of tool, you're basically loading it up in Excel, and it's much quicker to do it for me to do it from the command line using Python.
You started using any security tools. We started integrating our CI/CD pipelines with security tools such that when you bring in libraries and things, if we use Inspector to check to see if there's any criticals or highs, vulnerabilities, or to stop the build process.
Yeah, that's a good idea.
And also some of these libraries or some of these tools to look at like lint type of things where it's like if it finds anything that your code is not adherent to, it will stop the process.
Yeah, so the comment is like to leverage that CI/CD process to bring in security tooling as well. So not only doing like code cleanliness checks, or do security checks as well, like check for outdated versions of libraries being brought in as they're being put in, and stop the build process right away anytime there's a security violation. I like that idea as well. I mean, I think there's a lot of opportunity for CI that most people aren't. That's not just unit testing. There's so many more things you can do with it to try and break the things you're getting ready to deploy, or test for security issues, or test for code problems, code linting problems, things like that. If you have a code standard you want to adhere to, it's a great way to make sure that that happens without breaking the build someplace else down the line and making for more of a headache later. I have a whole nother talk about that, but that's for another day. So are we living the dream? Did we actually get our dream of masters of menus? And I would say we definitely have fulfilled this dream of taking a pretty much what was a non-cloud native application and deploying it in a way where we can now easily interchange building blocks and pieces, add more application servers as the load increases, or take away application servers as the load would decrease to actually save money. So I think from our standpoint, we were very happy with this. I would love to be able to implement some of the CI/CD things, but I think for right now the goals have been met, and I'm really happy with the technology and the set of tools we put in place to do it. If there's any questions, I would love to answer them. And thank you guys all for coming out for our inaugural IndyPy Bytes. Yes?
So for getting to spin up, scale it out for more instances, do you still have to manually go in and do that?
Currently, because we're not using auto scaling groups for this, but right now those definitions of how many servers are sitting in that load balancing pool are all defined in what's called a salt pillar. So you would just literally add 2 more servers, go run the high state process or state apply, and it would spin up the servers, download the code, do all the compiles, and put it in the load balancer. That's all automated. So the only thing we don't have is any way to, you could react. There's not a need for it in this specific application, but you could react if you needed to like that.
So we built a CI/CD for
Yep.
Amazon gives you to include all our stuff. Plus, once a month, Amazon's already updating and patching and stuff of all the stuff of their AMIs. So I was wondering, the auto scaling group is a great way
To do that.
to server, delete it, it'll automatically recreate it based upon the new AMI.
Yep.
And that's one thing I was wondering. I've seen a couple little test things out there, but using an auto scale group of one, because you only need one server.
Mm-hmm.
And that way you create a Lambda function, deletes that server once a month, for example, or once every week, or once every
Yep,
2 weeks.
I've seen this where some of the groups we've talked to have maximum time to lives on servers. No server in the infrastructure can last longer than say 2 weeks, and they get killed automatically, and the auto scaling group would bring back one in its place. So yeah, I've seen that implemented, and building custom AMIs that you would launch with your application already to go, that would greatly speed up this process I just showed you. Because right now ours is not so time sensitive, so we can wait for it to basically spin up the stock FreeBSD AMI, do all of our changes based on the SaltStack code. But tools like Packer from HashiCorp support building AMIs using Salt profiles. So I could actually take all the work I've already done here and just directly build AMIs and upload those AMIs as part of the release process, or put it into a Jenkins tool or Jenkins job to do that exact same thing.
And that's where we go back to Docker, because it's
Yeah.
ECS. I mean, that's beautiful. All that stuff just works great together. You just say, I want to kill it. It'll automatically bring up the EC2 underneath there, and automatically move the load over. So you go from, a short period of downtime to no downtime.
Yeah, to get to that zero downtime. So the comment there is, moving this then the next level using Docker and containers and ECS, it can now move loads around for you and basically eliminate any traces of downtime and manage all that resource infrastructure for you. I agree.
What do you use for production monitoring and tracing of how much load you have when you need to scale up?
Currently we use, oh yes, let me repeat the question. So what do we currently use for monitoring the load on the servers or tracing to see if we need to actually scale up or down? Right now, the servers are all monitored using an open source tool called Zabbix. We also, we proposed and put in place CloudWatch metrics, which we did put in place, but I don't know if they're looking at them. They didn't pay us to continue to look at them, but those are in place to actually watch, CloudWatch metrics. One of the other customers we're working with right now is using Datadog, and actually I like that tool a lot. It's kind of pricey depending on how many servers you have, but it does do some really nice job with giving you beautiful graphs and alerting and monitoring and kind of watching the real state of things. They've done a good job of sucking all that information out of AWS, but you pay for that because you pay for them to talk to AWS, and you pay AWS for them to talk to AWS. So be careful of the costs there. But yeah, so we've got a couple tools in place for that.